My name is Mohammed. I was working on configuring the keypad to be used in our project, Game Girl. We didn't need many controllers in our project because mainly we are going to up and down, so we didn't need it. So I just configured 1 and 4 as usable buttons to be used to go either up or down to avoid obstacles. Configuring the pins used for our keypad. Here we have the first 4 from left to right. The first 4 represent the rows here, and the other 4 represent the columns of the keypad. The first 2 pins are connected to 13 and 10, while the second 2 representing the columns used are 8 and 7. I define the size of my my keypad, rows and columns. In this part, I identify or I define a 2D array to show what are the keys that I have on my keypad. In this part, I define the pins that I use to program my keypad to show which of the buttons that will be working with me. And here I define the keypad, giving him the characters on my on the keypad that are available, which are the 1, 2, 3A, for example, and 4, 5, 6B. A 2D array defining the keypads, the content of my keypad buttons, and I give him the row pins and the column pins that are used, and the size of my keypad, which is 4x4. The player just click a button. I get the key using the custom keypad that I created in the beginning, and by getting it through a function called getKey, and store it in a variable type char to use it. If the user didn't apply any buttons to be used, custom key will store at 0.
My name is Mohammed Adel, 34-Engineering, Tutorial T10. I have worked on the LCD connections and the software implementations. This is the LCD, and to connect it we start with connecting the ground to K, digital pin 9 to A, digital pin 2 to D7, and digital pin 3 to D6. And then we connect digital pin 4 to D5, and then digital pin 5 to D4, and then digital pin 11 to enable, and the ground to RW. Finally, we connect digital pin 12 to RS, digital pin 6 to V node, and VCC to VDD, and the ground to VSS. And this is it, we're done. To initialize the new liquid crystal LCD display, we have to initialize some variables and the pins they are connected to on the Arduino board. And then we create 2 byte arrays, one for the player and one for the obstacle. And then to set up the board, we give it its size, and then we bind each byte array to the number it is.
My name is Waleed Zakaria, 34-Engineering, T20. In this game project, I was responsible for the obstacles mechanics and its generation. So first of all, I made a couple of modules for the objects that comes against the player. Here I made an array called module, and 0 here represents an empty block, and 2 represents a full block, which is an obstacle. So either I have a block and 2 empty spaces, or 2 blocks and empty space, or a full 3 blocks next to each other, or a block, then an empty space, then another block. After I made the module, the mechanism of the obstacles moving towards the player is done here. Here I make a number called gap. This gap makes sure that there is always space for the player to move and not be met by two obstacles next to under each other. I made a gap from 1 to 3. This number I use just to make sure that the gap is either 1 space, 2 space, or 3 space in this condition. But first, I made a random number from 0 to 2, 0, 1, 2, and that's to choose which module I'm gonna use in my obstacle generation. Here in this condition, I just check the gap, whether it's 1, 2, or 3, and I make sure that the last 3 places in the upper, here, that part, the last 3 places in the upper screen are empty. I have to make sure, and also the positions before it in the upper row. So the upper row and the bottom row, I have to make sure that the last 3 places are empty, and also another place, because this is gonna make the gap 1, not to overlap the obstacles with each other. And same thing with the gap 2. I have to make sure that the last 3 also are empty, bottom and up, and also there is another two places empty, in order to generate a gap of 2. The obstacle that's coming, make sure that there is a gap of 2. And the gap of 3, same, but I have to also make sure here 9, 10, and 11. Another space to make the gap only 3 blocks. After choosing which gap I'm gonna use, I generate a number, either 0 or 1, and that number just makes sure that the module that I'm going to post now is either in the bottom row or in the upper row. After that, here in this loop, I just make sure that the obstacles keep moving towards the player. So if the obstacle, which has number 2, is in I of j, I just make it move to I of j minus 1, and then its previous location to 0, on empty space. And that's it.
Hello, my name is Mohammed Tarek Kapiel, 34-engineering at T20, and I'm going to explain how the whole code works and how the different modules that my colleagues explained are connected. So first things first, after all the initialization of the LCD and the keypad with the character arrays and all that, we start to look at the actual game code. So the way we did it is that we created this sort of a backend and then draw right away into the actual LCD. So the way we have it is that we have another 2x16 array with different characters representing different things. So a 0 is an empty space, while 1 represents the actual player character. This is the part of the modules. This is related to how we create obstacles. So obstacles are presented by 2. And a few variables. Is game over decides if the game ended, if the player died or not. So if it's true, or 1, obviously lost, else it's the beginning, or they're playing a new game. And the difficulty is actually the speed at which it renders. So the smaller the number, the faster it is. It's the amount of loops or delays they have to wait. Now where do we need to go? Collision. Okay, first things first. The way we decide if the player died or not is to look through our back-end game array and to try and look for a character 1. If we find a character 1, okay. If we don't find a character 1 in the entire array, that means that the character obviously died, and we change the game state into is game over into false. And right after that, we actually check if the game is over, as in it's actually, that's it. All we have to do is render on the screen game over and ask the player to press to restart. After which we keep checking on the key presses and looking for any press, either the 1 or 4 key. If we do, then we reinitialize the game simply by putting the player back to his initial place. So the next iteration, this will actually be false and we'll go to the else statement, which is where the actual game code runs. So the first thing we do is actually check for the player input. The way this loop works is that if we are at the top, no, actually if we're at the bottom and we press to go to the top, I have to check. If there's an obstacle above me, the player automatically loses. So all I do is reset his current position. Else, all I do is take him up and remove him from the bottom. The same goes with the player being on top or on the bottom and trying to go to the top. It's the same logic, just mirrored. Here is the code related to generating the mazes and moving them. And here's the actual draw call. All this does is call a function called draw. Here we clear the LCD to start a new drawing session, set the cursor to the start, and iterate through our array and start drawing. If it's a 1, we draw the player created in character 1. If so, we just put an empty space, and if it's 2, we draw an obstacle on the screen. And here's the code that actually is controlled by the difficulty. Here we decide how fast or how slow the game goes. So we loop over the difficulty while getting the input from the character and moving accordingly. The way this works is that the bigger the number, the more iterations we have, the more time the player has to put his input. Otherwise, the input is actually ignored. And after each iteration, we actually speed up the game a little bit, adding to the difficulty. And that's pretty much it. You have a game.
Here we avoid the obstacles. Over time, our game starts to speed up, so you feel like there's a goal you want to reach, which is being the perfect one in this game. Boom, here it speeds up. Let's try to avoid these obstacles. I think this is enough.